Hello and welcome to this video titled Components of Computer Networks, Wi-Fi and DNA Center. In this video I'm going to talk about some common Wi-Fi components you'll find in most computer networks today, and I'm also going to give you an introduction to Cisco DNA Center. Alright, so what if I'm doing Wi-Fi? What if my laptop, my smartphone, my tablet is not connected to any physical wire, but somehow, magically, I'm still on the network. I can still, surf Google or get on Facebook or whatever. Well, that's because you have a wireless NIC. We just talked about that. It's got an antenna. Even if you don't see it, you've got an antenna. It might be built in as part of your screen on the side or something, but you've got an antenna in there. You've got a transceiver, which is basically a radio capable of radiating radio frequencies and receiving radio frequencies. And what's on the other side of that? What's picking up those radio frequencies? It's one of these, what's called an access point or a Wi-Fi access point. So in the case of a Wi-Fi access point, what you have here is you've got multiple clients, each with their own antenna. All right, maybe this is a smartphone right here with his antenna, and they're all connected to this access point. They're not physically connected, there's no wire connecting them. But when one of these guys first gets on the network, first thing he does is he says, okay, is there a Wi-Fi network around here somewhere? And the Wi-Fi client, let's just take your smartphone as an example. When wireless or Wi-Fi is turned on your smartphone, it's always listening. It's always listening to see if there's any Wi-Fi networks around. And you'd be surprised at the number of Wi-Fi networks it picks up. Right where you're standing, it might say, okay, there's a Wi-Fi network here which is called John's house. Well, I'm John, I'm in my house. Oh, I'm also hearing a Wi-Fi network called Bogart's house. Oh, that must be Keith Bogart's house. I'm getting his Wi-Fi. I'm also getting a Wi-Fi network called Starbucks, all within hearing distance. So the next thing your Wi-Fi client would have to do is associate to that network, which means it would actually send a Wi-Fi frame to the access point that is broadcasting that network. So somewhere there's one or more access points that are saying, hey, I own the Starbucks network, connect to me. Or I own the Jones network, connect to me. So if a client wants to connect to that network, it's going to send a Wi-Fi frame to the access point saying, can I get in? Can I connect to you? And there's going to be a series of steps that are involved, but once the Wi-Fi client has associated to the access point, now they can actually exchange data wirelessly. But you got to have an access point to make all that happen. Now, back in the old days, when access points first came out, we had what were called autonomous or standalone access points. So when you got the access point and you took it out of the box and you plugged it in, one of the first things you would do is on your laptop you'd have to connect to it would have like its own little web page built in, its own little graphical user interface. You would have to connect to the web page of the access point and configure it. You'd have to say, okay, let's see here, I want the Wi-Fi access point to advertise my home network, Jones Home or Sally Home, all right? And I want the access point to have these characteristics. The network's going to be this fast, it's going to have this kind of security, and you'd configure all of that on the access point. And then when you were done, you would stick it on your desk, stick it in the wall or the ceiling. The access point would actually have to have a network cable which connected back to a switch. But then your Wi-Fi clients could connect to the access point wirelessly, and then your wireless data from the access point would be put onto the cable and sent back into the wired network. Now that was all well and good when we had just one or two or three access points, but imagine for a moment a company that has dozens or hundreds of access points. It can get real tedious programming each and every one individually, sticking on the ceiling, and then what happens if 6 months later you need to make a change that's common across all the access points? Are you going to rip each one down from the ceiling, connect to their command line or the graphical user interface, their web page, and reconfigure it? Probably don't want to do that. So some people came around, they said, you know what? It'd be a much more scalable situation if we had some networking device that could control all of my access points. So rather than logging into each access point one at a time autonomously as a standalone access point, I'll just go to this other device right here, I'll program him, the access points will reach out to that device, and when they connect to that device, they'll find out how they should be programmed. And that is what we call a wireless controller. So a wireless controller is a box that controls multiple access points. It's a much more scalable solution, a central point of management for groups of access points. It can also control Wi-Fi access for the clients. You see, with an autonomous or a standalone access point, when a client, like your tablet, your smartphone, says, hey, access point, I want to connect to you, the access point will say, okay, sure, here's the security we use. The client will send across his credentials. Hey, here's my username and password. So that security exchange about, should I let that guy on the Wi-Fi network or not? Does he have the right credentials? That'll be a decision that the access point himself will have to do, which means in an autonomous or standalone access point, you would have to configure it to do that. Well, with Wi-Fi controllers, you can go to the controllers and you can say, hey, controller, I'm going to configure you. And now whether 2 access points or 50 access points connect to the controller, all the access points can be told, hey, all you access points, here's the type of security we're going to use. Here's, when somebody connects to you, pass them through to me, the controller, and I'll authenticate them and make sure that they're allowed on or not. So what's some differences between controllers? Because there's a lot of different companies out there that make them, a lot of differentiators. Well, one thing is the quantity of clients they support. Some of the higher end controllers can literally support tens of thousands of Wi-Fi clients all at the same time. The features available, do they have security features? Do they have other types of features built in? Are they appliance or cloud-based? Like what we see here, this graphic is an example of an appliance. An appliance in networking terms is a physical box that you can hold, you need to plug it in, that's designed to do a specific task. That would be an appliance. Like, okay, for example, your microwave is an appliance, right? It's a physical box. It's designed to heat up your soup or heat up your hamburgers. That appliance is different than your refrigerator, right? They're both physical things you can touch and feel, but their purpose is different. Same thing here in the world of networking. When we say, oh, I've got a network appliance, it's a physical device that's designed to do a specific task. So controllers, you can buy them and install them in your own company as an appliance, or you could do a cloud-based situation where you'd say, you know what? The controller, I'm not actually going to see it. I don't know what it looks like. It's in the cloud. It's reachable via the internet. So I'm going to reach out to Cisco or Meraki or some other company and I'm going to pay them maybe a yearly subscription. Once I pay them, now all the access points in my company can reach out through the internet and contact their controller. I still have access to that controller, so it still has a web-based GUI, but the controller's not physically in front of me. I can access that GUI, I can manage it, I can control it, but it's in the cloud. It's reachable via the internet. And the types and quantities of uplink interfaces. A controller is also going to have physical NICs, physical connections to wires. How many NICs does it have? How fast are those NICs? What kind of wires connect to that controller? Those are all differentiators. Okay, so the last component I want to talk about here. So I just sort of gave you the example of, we start out with access points being standalone or autonomous. Each access point managed, configured individually. And then we said, okay, not really scalable if I'm going to have any more than about 5 of these things. I like to have one central device called a controller which manages and configures all of my access points. Okay, let's take it up a notch. Imagine you've got a network that's got 500 switches, we've talked about that, maybe another 500 routers, maybe another 1,000 access points. Wouldn't it be nice if there was some central point of management for all of that stuff? Some central thing I could log into. It gave me a nice web-based graphical user interface that showed me in that one pane of glass. They call that a single pane of glass because I'm just looking at this one website, and through that I could see a listing of every single device I have on my network. I could configure all those devices. I could change them based on what my needs were. Wouldn't that be cool? Well, Cisco has come up with something that does just that, which is called Cisco DNA Center. DNA in this case standing for the Digital Network Architecture. So like it says here, Cisco DNA Center is a centralized management dashboard, not just for a bunch of access points, but for complete control of your entire network. This is going to blow your mind here, so just think about this for a second. provides a central automation and analytics platform to facilitate intent-based networking. What the heck is that? Talk about marketing speak. So what this is really talking about is, up until recently, when people were designing a network, their primary thought was, okay, how many devices, so imagine you have an empty building, okay? And it's your job to figure out what cables are going to go through that building, how many routers, how many switches, what makes and models of hardware you're going to buy and purchase. So these are, traditionally, what you would think about is, okay, how many hosts am I going to have in that building? How many laptops, PCs, network-based printers, IP phones? Okay, I got to think about that. What type of data are these hosts going to be doing? Is it just going to be web browsing? Is it going to be doing other stuff like, I don't know, sharing of music files? What are they going to be doing? And where are they going to be located throughout my building? Are they going to be in clusters? Are they going to be sort of evenly interspersed out? Am I going to need just wired or a combination of wired and wireless? So all of that stuff would help you design your network till you got to the point where you sat back like 6 months later and said, whoo, sigh of relief. Access points are all in place. Wires are all done. Routers and switches are in place. Everything's chugging along. Great. Now what happens if a year later somebody introduces a whole new application and the network you've got isn't really designed for that application? It's not really working as good as it could. This is where intent-based networking comes in. Intent-based networking says, okay, my network infrastructure is already out there. Okay, I've got my wires and my physical devices all plugged in. Intent-based networking says, based on what my intent is right now, the intent of what applications do I want to use? How do I want the network to react to those applications? Do I want the network to dynamically adjust throughout the day based on what applications are running and which ones are not? That's my intent, and I can use something like DNA Center to make my intent a reality. I can go into DNA Center and say, okay, we can't change the physical nature of the network. I can't make a router just vanish and disappear or make a switch, boop, there it is, it didn't exist before. I can't do that. But with intent-based networking, I can say, hey, let's dynamically adjust the network and optimize it so it's better for this application over here that just came online, maybe and penalize this other application over here. Let's push down some new wireless policies that didn't exist before. That is intent-based networking, taking your intent of what you want the network to do, which can change from day to day, month to month, year to year, and making that a reality by pushing down new configuration commands and stuff. And that's what DNA Center is all about. So DNA Center is an appliance. And remember, we said what an appliance is. It's a physical box you can touch and feel that you plug in somewhere that has special software in it called DNA Center software. And we call this a controller. Now you say, but Keith, you just talked to me about a wireless controller. Yes, but a wireless controller, the only thing that it controlled were access points, and that was it. The DNA Center controller can control access points, routers, switches, even servers out there. It can control everything almost connected to the network. Central point of GUI-based network control that allows you to design your network. So one of the things that DNA Center has in it is before you even lay down a single cable or purchase a single switch, it's got this little section of the GUI where you can sort of design a network. You can say, okay, what if I plug in a switch and a router here and I connect them up and see, how's that look? Do I think that's going to work for me? Instead of doing it on a piece of paper with chicken scratch and a pencil, you can do it within DNA Center. You can create topology maps and diagrams. You can identify golden images for software deployments. A golden image is basically a term of, let's take a network-based switch, for example. A network-based switch might have lots of different versions of software that can go on it. Like your laptop, right? With your laptop, technically there's Windows 95, Windows 7, Windows XP, Windows 10, okay? Well, at some point, if you're in charge of like 50 laptops, you're going to say, you know what, for our organization, we're going to standardize with Windows 10. That's our golden image. That's the one we're going to put on everything. We've tested it. We know it works. It doesn't have any bugs. That's the one we want. So that's what we mean here by a golden image, is we can say for our routers and our switches and our access points, here's the certain flavor of software we want all these devices to consistently run. We can even control our wireless stuff by creating wireless profiles and SSIDs. And this has a GUI-based configuration of network devices. So there's a lot of stuff on this slide right here that you probably don't need to know. The main thing is I want you to look in the upper left-hand corner, and you can physically see there the different flavors of the DNA Center appliances that you can purchase. And you can see it varies based clearly on its size, how much rack space it's going to take up, as well as how many devices it can control. You know, routers and switches and access points. Oh my! Lots of things the thing can control. And there's a lot of other stuff in here that is way beyond the scope of this video. So that's been a lot of stuff, I know, but that finishes out this video on network-based components. I hope you found it useful. Thank you so much for watching.